Hey guys, welcome to my channel. Tonight's video is about this reluctance, or some people call them attraction motors. And this is made from a vacuum cleaner motor. I just took the stator electromagnet out of it, and then I made a nice round steel rotor that you can see in there. So there's no magnets in this motor. It's all steel. So no rare earth, no nothing. And here's the back of the circuit. We have a MOSFET. Instead of optical timing, we actually have Hall effects timing right here. So you can see these two little dots. These are actually two little tiny magnets for timing. And then here's the sensor right here at the bottom. And then this is the high-speed diode for the output. The output comes out as yellow and white, and comes down and into this capacitor discharge bank. These capacitors get charged up to around 16 volts and then discharges into the secondary battery. Secondary battery charging up. It's starting at 11.74. It will be charging. Primary battery 12 volts, 12.9. It's just a 100 amp hour cheap as dirt battery, but works great for experiments. And then we have the Adreno. This just works as a speed control. Plugs right in the bottom of the motor right there. This motor actually could be full power, just turn on here without timing, or you could switch it this way, which lets you do a speed control on it, so that it could chop it up and control the speed. It's a really smooth running little motor. There's no like an Adams motor, you physically couldn't turn this, but this one, because there's no magnets, just spins smooth as silk. So we're going to start this up in a minute here. I have this big prop that we're going to put on later to show the load, but for now we'll just turn this thing on to give a little kick over to get it going here. Turn this up. So with the pulse width modulator, you could see the chops at the top of the screen. That's the power on. The bottom is actually the output, and you can see it going farther down and up, farther down and up. That's actually the capacitor is charging up right here. You can see it pulsing into the battery. Works quite well. So right now we're about 1/4 amp. I'm going to turn this thing up. This motor has a really clean little waveform when you get it up to full power. So real nice and clean. You can see the capacitors charging on the bottom, on the negative energy side. Full power, no load, excuse me. You have 1.5 amps. But as you load this thing, it really starts having a lot of torque. You could physically feel it and hear it. It could go up to about 5 amps in the waveform as it slows down. But what's interesting is when you load it down, now the output is really going. You know, we're almost up to 10 amps every pulse, and you can see that battery is charging pretty quick. So what we're going to do is shut this down for a minute and put this prop on so you can see it with some regular load. It doesn't just burn my fingers. So pretty good sized prop for this little motor, for only having one circuit without it. You know, it's really only on about 50% of the time. So you could hear it as it discharges. The motor tone changes a little bit. You can see all the chops from the pulse width modulator. So we're going to start turning this thing up real slow. You can hear the torque of the motor shaking the whole table. here's full speed. Pop's going pretty good. It's a little over 1,000 RPMs or so. The lower RPM of this motor is very, very torquey. See, we're using a little over 4 amps, but take a look at the output now. This is pounding away. Right there, 9 amps. It's charging that battery up pretty quick. What's even neater is if we take this pulse width modulator and we can adjust it down just a hair. Slows the motor down a little bit, but you can see it starts putting extra pulses in. And now look at using less power now, but we're having just as good output. It's amazing to me just the sound of this thing running. It hits so hard every pulse that it just shakes this table every time it torques over. Pretty neat. Just need to make a lot bigger one. It's real nice because you don't have to spend a lot of money on expensive magnets. The rotor is actually just plain old steel. I think this one was cold rolled steel, and then I just used a hole saw and cut it out into an oval shape, and then just worked on the timing until I got it right. Let me know what you guys think. Thanks for watching my channel.